Hello, everyone. Today, we want to know what valence electron is. What is valence electron? Before we answer that question, let's refresh our memory about the structure of an atom. Let me build an atom. We have protons, we have neutrons, and electrons. We build a neutral atom. Now, we have to understand the modern day atom looks like this, but we are using Bohr model because it's more convenient. Now, in this atom, there are two energy levels. There's first energy level. The energy level, we count it from the inside. The one closest to the nucleus is the number one energy level. So this is number one energy level. This is number two energy level. This is, in this atom, this is the highest energy level, or we can say the outermost energy level. And now there are two electrons in this first energy level. There must be maximum of two. After two, the next one we have maximum of 8. But this time, beryllium has 4 protons, 4 electrons. This is neutral atom. This reminds us about what neutral atom is, no net charge. So this can hold maximum of 2. The remaining goes to this. Okay, but this second energy level can hold maximum of 8. If you want to draw Bohr model, all you have to do is to look up that element in the periodic table. In what period is that element? If the element is in period 1, it has energy level of 1. If it's in period 2, it has energy level of 2. Beryllium is in period 2, therefore it has energy level of 2. Okay. Hydrogen is in period 1, it has energy level, only 1 energy level. So it's important to understand that. Okay. Okay, let's look at this. We talked about beryllium. Beryllium is in period 2, therefore it has 2 energy levels. Period 1 has 1 energy level. Period 3 tells us that it has, all the elements in period 3 have 3 energy levels. You have to understand that. Okay. So with that, we can look at this, get your periodic table out, and write the number of energy levels for each of these. How many energy levels? Please pause the video, get out your periodic table, and get your answer. So hopefully you did. So hydrogen is 1 energy level, calcium is 4 energy levels, sodium is 3 energy levels, neon is 2 energy levels. Okay, hopefully you got that right. Another thing I want you to do now is to, in each energy level, write down how many electrons in each of these energy levels. Okay, think about it. How many in each energy level, how many electrons do we have? Let's do it together. This one, hopefully, you see 2 electrons. This yellow, like, are the electrons. There's 2 here. This one, 1, 2, 3, 4, 5, 6, 7, 8 electrons. This one, there's 2. This one, there's 8. Then the third energy level has 1. Then this one, there are 2. This 1, 2, 3, 4, 5, 6, 7. Okay, now Let's look at what valence electron is. Valence electrons are electrons in the highest energy level or in the outermost shell. So also, we have to remember the electron configuration. This is the electron configuration of lithium. We can also put it in abbreviated or noble gas notation also. Here, if you are asked what is the valence electron here, the first thing you do is to ask which of these is the highest energy level. Hopefully you say 2 because these big numbers are the energy levels, where the small number is telling us the maximum number of the electrons in this orbital. Okay. Then this one, there's 1 electron here, but the energy level is 2. So this is the second energy, that's the highest energy level. In this energy level, there's only 1 electron. So this is the valence electron, number of valence electron here is 1, which is the same as this. This is written abbreviated. So when we are looking at the highest, we are looking at what is after that abbreviation, after this. Okay, so this is also 1. Then here is the same lithium. There are 2 energy levels. This is the outermost or the highest energy level, this one. Remember, this one is energy level 1. That's not the highest. So this is the outermost or highest energy level. So it has valence electron of 1. Okay. So valence electrons are generally the electrons that are furthest from the nucleus. Furthest from the nucleus. And the importance of valence electron is that they determine the properties of an element. That a reaction is happening depends on the valence electron. That's what does that's the interaction. Valence electron participate in interaction with other atoms. This, like for this lithium, when there's a reaction is between this and other atoms, valence electron of other atoms. These ones are not taking part. It's only the valence electron. So it's very, very important. So with that said, determine the number of number of valence electron from these images. Okay. The valence electron from these images are what? Pause the video and get your answer. Okay, hopefully this one is 8 valence electron. That's the outermost. The number of electrons is the outermost. 1, 2, 3, 4, 5, 6, 7, 8. This one, there's only 1. Okay? 1 valence electron. This one, there's only 1, 2, 3, 4, 5, 6, 7. Okay? Hopefully you got it right. Let's look at the periodic table. Hopefully we remember we know that there are 18 groups, 1, 2, 3, 4, 5, up to 18. Then, and we know that the special groups, we have alkaline metals, alkaline earth metals, which is group 2. And then we know there are halogens, that's group 17. Then we know that there are noble gases. Then we have transition metals. This section are called transition metals. We have lanthanides, which came from this name, actinides, which came from this name. Okay, now there are what we call main group elements. These elements, we can predict their valence electron. We can predict how the group reacts. So this, if you look at this number, you see 1 to 18, but there's another number, 1A, 2A. Now we have B's. Then we have 3A, 4A, 5A, 6A, 7A, 8A. There are 8 groups that make up this section. So these group 1A through 8A, excluding this transition metal section, are called main group elements. They are called main group elements. So let's look at these main group elements. Okay, look at it. This is main group, okay? These are main groups. This is not. The ones in yellow are main group elements, okay? Now, we have to see how we can use these main group elements in predicting the some properties of a periodic table. Okay, now this is main group elements. If we look here, we find out that with this, we can say that each group, look at this is main group elements. Remember, there's no more transition metals. It's not here. We are looking at only main group elements. And when we look at these main group elements, we can predict a lot of things. We can see clearly that all the valence electron in this group is one. They're the same. Look at that. This has one valence electron. 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 And here, this has two, two, two. And then the valence electron here is three. The valence electron here is 4. The valence electron here is 5. So each group have the same number of valence electrons because the property, remember, the property of an atom depends on the valence electron. So these groups have similar properties because they have the same number of valence electrons. And we can also see that the valence electron is increasing from left to right. This is 1, this is 2. This is 1, 2, 3, 4, 5, 6, 7, 8. You see that? It's increasing as you go from left to right. Okay? Let's refresh our memory again. Valence electrons are electrons in the highest energy level on the atomic shell, and we looked at this, okay? They're generally electrons that are furthest from the atom, and they determine how an atom reacts because it's when there's reaction, the valence electron interacts with valence electron of other atoms. Now, we have to do some practice question. Hopefully you understood it. So you pause the video and write down the valence electron for the following. Here are the answers. Here, it's only one valence, energy level 1, 2, 2, 3. So in this third energy level, there's only one valence electron, okay? Here, first energy, the second, there are 2 highest energy level here. So we have to add this and this up. 2 plus 5, 7 valence electrons. Here, 1, 2, 3, 3. There are 2 highest energy levels, so it's 2 plus 6, that's 8. Then this one, number 4, that's the highest, so there are 2 valence electrons. Look at this one, 5, 4. This is the highest. So the valence electron is 2. For this one, the outermost, 1, 2, 3, 4, 4 valence electron. There's only one valence electron. Here, 1, 2, 3, 4, 5 valence electron. Hopefully you got it right. Now, there's an easy way of knowing the number of valence electrons. Easy way. It says elements in the periodic table are arranged in groups. Each group has the same number of valence electrons. This is referring to only the main group elements. Main group elements. Remember, transition metals are not part of it. It's group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. How does that work? That means if element is in group 1A, it means the number of valence electron is 1. If element is in group 1A, it means the valence electron is 1. If element is in group 2A, it means the number of valence electron is 2. It's not applicable to transition metals. If element is in group 3A, it means the valence electron is 3. Group 4A means every element here has group 4 valence electrons. Group 5A, 5 valence electrons. Group 6A, 6 valence electrons. Group 7A, 7 valence electrons. Group 8A, 8 valence electrons except helium. But helium doesn't have 8, but it's in group 8. Okay. Pause the video and see if you can do this before we do it together. So here we go. Carbon is in is group 4A, therefore 4 valence electrons. Sulfur is group 6A, 6 valence electron. Selenium is 1A, 1 valence electron. Neon is 8A, 8 valence electron. Okay. Now, using the main group elements, that main group periodic table, I'd like you to write the number of valence electrons for all these elements. Pause the video. Pause the video. Hopefully, you got these answers. Then I have this challenge question for you. Try to do it. There's no answer for this, but I believe you understand it. Okay? Thank you for watching.